HPA, okay, that is horizontal pod auto scaling. Why it's called horizontal means one by one we'll keep on adding the number of pods horizontally. Okay, so suppose there are by default only 2 pods. Okay, then based on the increase in the load, we can keep on adding it. Okay, so we need to install some metric server which will continuously monitor, okay, the deployment for the number of CPUs and RAM. If it is short of if it sees that the load has increased, it will tell HPA, that is horizontal pod autoscaler, will be creating a resource called HPA, and it will check what is the desired percentage. Based on desired percentage, what should be the number of CPU, number of pods which should be added or removed. Okay, so metric server is important. It will check for the usage, and based on that it will increase or decrease the number of pod, that is scale up or scale down. So we'll be creating a deployment. Okay, and in deployment we'll define CPUs. Okay, so here we have defined CPU, it is in millicores. Okay, 500 millicores. uh, then we will define a horizontal pod autoscaler, where we'll say that how many minimum pod should be there, at least one should be there, and maximum based on the utilization it can scale up to 10, not more than that. Okay, we cannot have any infinite number here. Okay, we need to restrict it to some number, and we'll also define here the utilization. Okay, based on the CPU, if it is 50%, here it is defined 50%, then between 1 to 10 it will keep on adding the number of pods. Okay, so here we can limit the pod to use only this much amount of CPU and RAM. Okay, if this much amount is above 50%, okay, it will try to add one more pod. Okay, and when the load again decreases, it will remove that pod. So this we will learn here in the lab. So let's delete whatever we have first. kubectl delete all -f and all. This will delete everything here in the current namespace. We don't have anything. kubectl get all. So let's check the number of nodes we have. We have only one node. Okay, we can check pods in all the namespaces using this command -a. Only in cube system we have some pods. Okay, system pods. Now we need a metric server. Okay, so if you see, it is possible to get the details of the CPU and RAM for the node and pod using this command kubectl top. Okay, nodes. Okay, the same command which we use in Linux as well. Top command gives the, if you see here, this is the top command. This is the Linux top command actually, which gives the load average. Okay, which process is using how much amount of CPU and RAM. You can get using top command. Similar to that, we have in Kubernetes kubectl top nodes and even top pods. Okay, but it's not giving any details because the metric server is not available. In short, it's saying that metrics API not available. So we'll install it. Okay, for that we'll be using some manifest which are given in this file. Okay, component.yml, and this file is available over the internet. Okay, and on the fly without downloading it, okay, we are applying it. So if you see here, what we are doing at this location, we have this file which is a metric server. We are directly applying it. Okay, so at the back end it has downloaded and applied it. If you see, we don't have anything here. Okay, but still if you want to check, we can go to temp directory and wget this file. So it also has some manifest which are already created, which we can use. Okay, If you see components.yml, it has service account, cluster role. Okay, various details are there to install a metric server. Okay, so it also uses some image. So metric server 0.7.1 it is using. kubectl get nodes. Let's see how many nodes we have. Get nodes. Now let's see what is the load on that. Let's first check the namespace if it has created. kubectl get namespace and kubectl system namespace. Let's check something there. -n. In kube system namespace, get all the details. So if you see, it has installed the metric server by default in the kube system namespace. Okay, this metric server will give us all the details related to the usage. kubectl top node. So if you see, it is saying 52 millicores are used by this node. Okay, that is 2%. 51111 memory is available. 15% is used. Okay, so similarly we can check for the pods also as well, but here we do not have any pod, so it is not really displaying anything. Now we'll create a deployment. Okay, and where we'll set that it should use 0.25 CPU. Okay, and this much amount of RAM, this is the requested, and some limit also will set. Okay, it cannot go beyond this, and this much it should use. Okay, that deployment we are creating now. Yeah, again using this command in for all the namespaces we can check here. Okay, how much CPU and memory each pod is using in kube system namespace. As of now we have only pods in kube system namespace. We'll create now a deployment cat httpd deploy.yml. Apply it, kubectl apply httpd deploy.yml. Okay, so just a simple deployment with some limits set. Okay, maximum which it can use and minimum which it should use. kubectl get all will keep the deployments and pods. Okay, so let's check its usage. So we don't need to check its usage, it's required for HPA internally, but we should also sometimes check that kubectl top nodes and top pods. Okay, so not much difference, very less amount of CPU and RAM it is using. So we have deployed it. Now we'll create an HPA. Okay, that whenever it crosses 40%, okay, it will increase the number of pods up to 4. Okay, so we'll define and maximum replicas as 4. You can even define it 2 or 3 or 10. Okay, but in this case it is 4. So we are creating a HPA, okay, resource in a default namespace for which deployment we should give the proper name. Okay, this is my httpd deployment which we already have. So it will check the average utilization 40%, and based on that, means we are checking the CPU. We can also check the RAM, but in this case we are checking the CPU. So let's create this HPA. We'll see my HTTPD. HPA.yml. Control D. Let's first check if you already have any HPA. kubectl get HPA, no resources in default namespace. Let's apply it. Now let's check kubectl get HPA. Okay, so initially it will show unknown. Okay, but after some time it will properly show the number of usage. So we have defined HPA. Let's do kubectl get all. Okay, so if you see now it says that actually it is created. It has only a small pod and no load on it. Okay, now we are not in a production environment, so and nobody is using this pod, okay, or a deployment, so we need to manually increase the load on this pod. Okay, for that we'll be using some commands. Okay, but remember we need to increase the load inside the pod. Okay, in a particular pod, sometimes what we do is we directly try to increase it on this VM. This VM is not part of the cluster. Okay, so we need to increase it in the particular pod. So for that we'll be using some commands. Now let's go inside the pod. Okay, and we'll download some commands like stress and all. Okay, stress ng commands will download, and we'll run the stress load inside it. kubectl get pods. kubectl exec execute an interactive terminal -it for this pod -f/bin bash. apt get update. And stress ng. So we can use only the stress command, but stress ng gives it properly. So here is the command. Stress and stress ng both we are installing inside the pod. Now using stress ng command, we are saying for 600 seconds. Okay, so what we'll do is we'll create one more terminal here. Open one more terminal. kubectl get all. So actually if you see, it has, while downloading, okay, it somehow the load got increased and it automatically spinned up one pod. Okay, so we didn't even use the stress command, and it automatically added one more pod when it saw that usage was more, but still We'll try to do that again using the stress command. So we'll continuously watch kubectl using watch command. We can do kubectl get pods. So let's see, it has already increased one pod, but after some time it should increase one more. But our HPA demo is already done. It added one more pod when the load was high. Okay, see, it started creating two more pods. Okay. Not more than 4 it will create, because the max limit is 4. Okay, so our demo is successful. So we'll just stop it. It was meant to be for 600 seconds. We'll stop it. Okay, and after almost 10 to 15 minutes, it will again remove the remaining pods. Okay, so I'll keep the screen like this only, and you all just practice. This one is easy. HPA lab manual scaling is, I would say, just practice this one, auto scaling using HPA. Okay, so at 7:30 we'll take the next topic. So the same link EKS at the end, and in that EKS do the HPA lab. I would suggest this one is not so important, and I'll keep this screen open. Just have a look on it, that after some time this will scale down. It will be back to 1.